Hi, and welcome to our third video in the FieldServer QuickStart series brought to you by Sierra Monster Corporation. My name is Mac, and today I would like to spend a few minutes discussing how we approach configuration of FieldServer gateways. This video is applicable to both the FieldServer X30 and QuickServer products, but excludes configuration of easy gateways as we do that very differently. Before we explore the structure of a FieldServer configuration, we need to understand a few key terms that define the basic principles of communication structure. The first of these terms is client and server. In the office environment, these terms are well understood. Office computers in the network called servers store data for us and allow us to access this data and change it with our laptop or desktop computers, which are the clients in the system. In the controls environment, clients still request and update data. These are usually the HMI workstations in the system, or recently, more typically, some kind of web user interface. Our servers, therefore, are the various pieces of field equipment that provide this data to the client. In an environment where all of this equipment is all on one network, this can be quite easily understood. However, when it becomes necessary to insert a gateway in between the client and the server, then one has to ask if the gateway is a client or a server. The answer is that it is both. There is no longer just one network in the picture, there are at least two, and the gateway will need to act as a client on one network to request data from servers and then turn that operation around and serve the same data on another network to the client. So you will see when programming the FieldServer product that typically you will need to provide configuration for a client and a server. The next concept to understand is passive versus active. In any communication, there's at least one passive component and one active component. Think of verbal communication. When a person speaks, somebody else is listening to what is being said. The speaker is actively pushing sound waves to the listener, who does nothing but receive the sound waves as they reach the ear. What's important to note is that the speaker gets to decide when to push the sound waves and how often to do it. So the speaker has full control of the communication, and we refer to the speaker as the active component while the listener is passive. With data communications, the concept remains the same. There are many communication models that define when the active component should communicate and how, but it remains true that there's always at least one active component and one passive component. This is important to recognize, as a communications configuration that is missing an active or a passive component will simply not function. If a person talks to themselves or sits in a room listening to nothing, that's not recognized as communication. Now, typically clients function as the active components to the network, and servers will be the passive components. But there are numerous situations where this does not hold true. Fire panels, for example, which are servers, usually function as the active components to allow for fire alarms to be expedited to the client. Communication protocols that are peer-to-peer act as passive and active components at the same time. So we need to understand our protocols and how they function if we are to configure them correctly. So let's look at a model of how the FieldServer configuration is arranged to manage all of this. This slide will introduce the terminology used in the FieldServer configuration so that the actual configuration will make more sense when you look at it in the configuration itself. I highly recommend that you still read through the FieldServer configuration manual found on our website before attempting a configuration. But hopefully this video will at least provide you with the backbone needed to put the various pieces of the information provided into place. In order to make this more understandable, we'll use an example of a Modbus to BACnet configuration where we're reading 3 Modbus devices through an RS-485 port and then serving that data up into BACnet IP. We'll follow the data flow of this model from server to client, understanding that there's also data flowing from client to server, but just to keep it linear, we'll start down on the server node over here and talk about what we're configuring. Now what you're looking at in this slide is the purple area being the field server and everything outside of the purple area being field devices. So we will start in a configuration by defining the client side connection, which is the blue box that you see over here, and that is defining the RS-485 port in this example, and we will define typical RS-485 parameters like port, board, parity, etc. So that's where we'll define the connection, and we'll need to start there, remembering that some field servers have multiple RS-485 ports. And so for those field servers, we give each port a name, R1, R2, and so we need to tell the system which port we're actually going to fetch the data from. Once we have the connection defined, then we are going to want to define what we call the nodes, which are the blue circles here. Now the nodes represent the field devices out in the field, in this case the three Modbus devices, and so we will declare three nodes. And for each node we're going to define the station address of the Modbus device. We're going to let the system know which port we're fetching the data through, so that's important as well. And then we will give the node a name so that we can reference it up here in the map descriptor section. So each node gets a name which you get to allocate. So once the name is defined and all its related parameters are in, we move to client-side mapping. Now client-side map descriptors is just a fancy word for mapping, and this is where we do the mapping of the data from our server nodes out into the field into our internal memory storage area, which is called data arrays. So data arrays is a very important concept in the field server, because in reality what we're really doing everywhere in the field server is we're mapping points in and out of data arrays. So a data array can be seen as an addressing system for the field server, if you want to look at it that way, or alternatively just think of it as a database, and it's something you can define inside of the configuration. You can define how many databases you have, or tables if you want to call them those, okay, and you can define how large those tables need to be. But the purpose of the data arrays are literally to store the data that we fetch from the field. So back to our client-side map descriptors. We're mapping data from the server node into a data array, and in order to do that we need to be able to do the following. We need to be able to say, go to this Modbus device, fetch the following registers, and store them in the data array starting at this offset in the data array. So that's exactly what our mapping does for us, and in order to do that it needs to reference the node that has been defined, and it needs to be able to state to the field server whether it's the active component in the communication. Remember what we've just discussed on that, and in this case, because we're reading data from the Modbus device in the field, we are the active component. We'll go out, we'll read the data, we'll decide how often we want to read the data in that mapping, and then we will decide where we're going to store it in the data arrays. Now, where we store it in the data arrays will also depend on data types. That's getting a little into the advanced section of it, but each of our data arrays have the ability to be declared with a certain data type. So you can store data as a floating point value, or you can store data as an integer value or as a binary value. That's up to you, but that all falls into the realm of storing data correctly and deciding how many data arrays you're going to have. Now, you can expect to have a lot of client-side map descriptors, because in each device we'll probably have to do quite a few mappings to get all the data we need. It's not typical that we can just grab it with one mapping. And then we'll have multiple devices, so a lot of mappings per device, and a lot of devices leads to a lot of mappings in total. But once we're finished with all of our mapping, then what we're going to be left with is all of our Modbus data sitting in the Modbus data arrays. And once it's in the data arrays, then it becomes protocol neutral data. And by that we mean we don't care anymore which protocol put the data there. It's just data in a data array. And when we have that situation, we can then turn around and serve the data up into BACnet. Now, BACnet would like to come fetch this data that's in the data arrays, but it doesn't understand the concept of data arrays. Data arrays is a field server concept, not a BACnet concept. So everything we're doing on the server side is representing this data that we have in the data arrays as BACnet information, so that BACnet's able to pick it up. So we start by defining a connection again. In this case it's an Ethernet connection, so our two Ethernet ports available in FieldServer are N1 and N2 on some hardware platforms, and so we may declare N1 as a Ethernet port and a BACnet server. And then our next step would be to declare device instances for BACnet to come and fetch. So in BACnet, device instances are equivalent of station addresses in Modbus. And what's really neat about the field server is that you have the ability to declare one device instance per device that you're representing. That's not typical, not all devices allow that. So if we had three identical devices down here, we could set our mapping up here so that it's identical as well. Now, once we have device instances declared, our next step is to give each of these pieces of data in the data arrays a object instance so that BACnet can actually refer to them. So that's the purpose of our server-side mapping. And our server-side mapping will say this piece of data over here in this data array can be represented as, for example, analog input 1 on, for example, device instance 11. And that's what our server-side mapping will do for us. It will just represent each of the pieces of data, maybe add some properties to it so that it makes it very readable. And then when our BACnet device comes and says, please give me device instance 11, analog input 1, we'll go, well, that's that piece of data over here. Here, have it back with all the properties we've declared as well. And then we're finished mapping all of our data. So by doing that, that's pretty much everything we need to do to get our data from Modbus through to BACnet. What you will notice is that we never once actually mapped data directly from Modbus through to BACnet. We map data from Modbus into our data arrays, and then we map data out of our data arrays into BACnet, and that's how we get our data there. This is a very important concept. This is what allows us to put any two protocols together. It's what prevents protocols from interfering with each other, which is a common problem in other gateways. So we have total separation of protocols, we have total separation of timing, and so it allows for good clean operation throughout. And that is the end of this quick start presentation. Please look out for our next presentation, which will walk you through a configuration file and apply the concepts we discussed here. Please like us below if you found this useful, and let us know in the comments if there are any features or functions you would like to see a video on. Thank you once again, and all the best with your field server application.